Your RAG system works on your laptop. But would you actually bet your job on it? Would you let it answer customer support tickets at 2 a.m. without supervision? Most AI systems fail in production not because the model is bad, but because nobody measured it. Vibe checks are not engineering. It looks good to me is not a metric. Today, we stop guessing. We build a judge. Let's look at the standard pipeline. User asks a question. Retrieval finds chunks. LLM generates an answer. It answers correctly most of the time, but most of the time is dangerous. What happens when it hallucinates? What happens when retrieval misses the key fact? We need tangible engineering metrics. Accuracy. Is the answer factually correct? Relevance. Did we retrieve the right chunks? Completeness. Did we answer the whole question? Consistency. Does it answer the same way twice? Without these numbers, you are flying blind. It starts with a golden dataset. This isn't just random query logs. This is a curated set of questions where you know the right answer. We call this the ground truth. Here's what it looks like in JSON. We have the user question, and we have the expert verified answer. This specific pair is our unit test. If the AI deviates from this ground_truth, it fails. Simple as that. Now, let's look at the system we are testing. This is a standard RAG function. We take the question, we retrieve context, omitted for brevity here, and we prompt GPT-4. The output of this function is the RAG_answer. In a demo, you'd print this and say, wow, it works. In engineering, this string is just an unsanitized input to our evaluation pipeline. Enter the judge. This is an LLM-as-a-judge pattern. We use a highly capable model, often stronger than the generation model, to act as an impartial arbiter. Here is the prompt we send to the judge. Look closely. We provide the question, the ground truth, and the RAG answer. We explicitly tell the judge, you are an expert evaluator. We ask for specific scores on a 1 to 10 scale. Accuracy, is it factually right? Relevance, is it concise? We force the model to return JSON so we can parse it programmatically. No free text essays, just data. Now we have numbers. We define a pass_threshold. Let's say 6 out of 10. If the average score across our metrics dips below this line, we have a failure. Why is this critical? Because LLM failures are silent. A traditional API crashes with a 500 error. You see it in the logs. An LLM confidently lies. It returns a 200 OK. Without this logic, you never know it happened. When a failure is detected, we trigger an alert. In production, this pushes to PagerDuty or Slack. It logs the exact question and the failing score. Now your AI system is observable. Conversely, when it passes, we log it as a success. Over time, this builds a confidence score for your entire deployment. You can say our system has 94% accuracy instead of it feels pretty good. So, we wrap it all in a loop. For every item in our golden dataset, we run the RAG system, we invoke the judge, and we record the result. This is your regression test suite. You run this before every deployment. If you change your prompt, run the suite. If you switch from OpenAI to Anthropic, run the suite. If the score drops, you do not ship. That is engineering discipline. Content creators stop at hello world, but real AI engineers build shields, memory systems, evaluation pipelines, safety guardrails. This is phase 4, production readiness. If your AI answers incorrectly, you must know before your users do. You cannot improve what you do not measure. Next time, can we hack this RAG system? Prompt injection strategies. Day 7. If you want to build production AI, follow and subscribe. Day 7. The guardrails. We build a firewall to catch malicious prompts before they hit your model. Because in the real world, people will try to break your bot.